Hello, everyone, and just a huge thank you to everyone for joining us today for today's panel. We're talking about de-risking releases at the speed and impact of AI. This is a lead dev online panel discussion created in partnership with Harness. Discussion is going to last about 45 minutes, after which both myself and the panelists will head over to the lead dev Slack. If you have any questions, you can ask throughout here. And then if they continue, or if you want to continue the conversation, that's a wonderful place to do is the hashtag panel Q&A. For those joining us live, I'm going to share in the chat right now the link to that lead dev, and I will add it as a resource because it's not ephemeral. Or it is ephemeral on Zoom, but it's a really great community, and I do recommend joining it. I like a Slack community. I don't know others. So yeah. So we'll answer questions if they see fit throughout. Otherwise, like I said, we'll continue on there. So you have the Q&A tool, please use it. So let's get started with some introductions. I'm Jennifer Riggins. I'm a technology journalist. You may have seen me host a lead dev panel before. And today I'll be joined by three lovely panelists that I invite each of you to introduce yourselves. Claire, you are at the top of my screen, so I let you go first.
Thank you very much, Jennifer. Long time lead dev fan, right from the early days. So lovely to be on this panel. Currently Director of Engineering at N8N, heading up all of the enterprise side of engineering there. Spent a lot of years working in tech across the globe, but based in the UK. And some of you may have seen me more recently on panels representing Netlify. Recently joined N8N for a new scale-up challenge. Maybe ping that over to Liz now.
Hi, I'm Liz. I'm a technical fellow at Honeycomb, and I previously worked for Google as an SRE for something like 11 years. So I've been around this block of tension between release velocity and reliability for years and years and years, and I'm very excited for what the future holds. Ryan.
And hi, everyone. My name is Ryan Vila. I'm a feature management and experimentation advisory director here at Harness. I have the opportunity to work across a broad spectrum of organizations who are implementing feature level observability within their groups, and I'm excited to share, my experiences working with them with you.
Okay, just a little background as people are jumping on. They came to hear from y'all, but at least in open source, the use of generative AI directly drives a 3 to 5 multitude increase in lines added in the first adoption month. In projects, this gains dissipate after 2 months. It's not a bad thing. Lines of code, not usually a great metric for anything, but I think it's actually a pretty reliable predictor of complexity. So while we don't want to measure lines of code at an individual level for various job safety and security and psychological safety reasons, it's not a bad one to measure your complexity of your database. So also it's been observed that persistent technical debt accumulation, static analysis warnings have increased by 30% and code complexity increases by 41% post-adoption of AI. The 2025 DORA report, which I'm a journalist, I love these percentages and things, said that AI tends to increase pull request size by 154%, which of course is increasing dramatically that blast radius of any release. And I think Dora said it very well, that it called AI an amplifier and a multiplier. So honestly, I don't think AI changes the things, because if you were doing the DevOps and engineering best practices and guardrails that we've been talking about for years, AI, you should be logically able to keep up with this new pace. You probably also aren't releasing as much. You're not adding that many lines of code because your quality checks are in place and things. But it is, if you don't have those in place and you don't have these progressive delivery best practices that we're going to talk about in place, well, every release runs a certain risk, but the larger release and especially those written without the checks of human beings in the loop, run the risk of more damage to your reliability, security, reputation, and bottom line. So we're on the call. Spoiler alert. We're all big fans of this idea of breaking work into smaller, manageable chunks, reduces risk. It's not an original idea, but this idea of then progressive delivery practice that can reduce that blast radius more. And these are just so much more important in the face of managing deployments with unpredictable AI elements are involved. So yeah, that's our topic. That's what we're talking about today. So we can help you figure out how to have the smaller, more manageable releases and the smaller, more manageable code and impact. And I know from the questions ahead of time, there was specifically people looking for how to do that under this idea of enterprise breadth and complexity of code. So without further ado, I like a definition. To start off, Claire, would you like to define what you think progressive delivery is?
I think there's people that have defined it better than I can, but I can certainly describe what I would expect as to happen. So for me, progressive delivery is rolling out smaller feature sets to a subset of the audience. So you can constrain it in two different ways, as in who is affected and how much of the new thing you're pushing out there, and whether you're running things in parallel. Commonly done with feature flags and canary rollouts and things like that, but I don't necessarily want to dig into specifics like that right now. I think the bigger conversation is more about how we wrangle all of this.
And then something you did mention about progressive delivery that I thought was very interesting, that there's a correlation between companies that do have the practice of progressive delivery and like positive work environment.
Yeah. So I was a big fan of feature flags from when I first encountered them at GitHub a long time ago now, many years ago. But I have definitely then seen other companies that they're just not even aware of them, or why you want to use them, or having the maturity to design changes that can take advantage of them. I think that this is to the point you're making there. This ties to me the trimodal nature of tech companies, where you've always got people who are pushing the bleeding edge, whether that's AI or anything else, but it's adopting the good practices, it's doing the DevOps, it's doing all of the things we've been talking about for a while now. Then you've got the kind of leaders within countries that are not necessarily completely there, but are doing their best and trying. And then some people are on cloud migration still, okay? How long have we had cloud? They're the kind of third tier of ones, and they're the ones that even now I would suspect don't have the organizational capability or even the infrastructure capability to do progressive rollouts. This is like back when I started with gold CDs being pressed for your master version of the software that you released. Just dating myself slightly.
Ryan, yeah, what do you want to add to that on the psychological safety?
Oh yeah, progressive delivery is a very interesting topic to me. I've been preaching it for a very long time, specifically around using, obviously, feature flags to kind of support that type of behavior, although there's other mechanisms to do that as well. But I was just thinking about psychological safety. I was thinking of a conversation that I had with a VP of engineering at one of the largest credit bureaus, in the world. And they were talking about kind of their efforts around application modernization, which is also kind of a buzzword, and you hear a lot of people talking about it. They were very interested in kind of helping their engineering workforce modernize the tools that they were using. They were using kind of legacy languages. They wanted to take advantage of, more modern architectures. And they thought, as an organization, that if they did this modernization, they would see an acceleration then in new capabilities coming to the market, right? Just a higher velocity rate. What they discovered was that they did modernize their tech stack and they were using more modern architectures. Unfortunately, it was having the unforeseen consequence that a lot of the testing was shifting, they were shifting to more testing within development because they didn't have as much experience working with these modern technologies and stacks. And so they felt like they had to compensate with testing more. And so actually things slowed down as they kind of ramped and adopted these new technologies. It wasn't until they started using feature flags that kind of created that safety net that they then saw an acceleration because psychologically for the engineers, there was less risk in that release process. So great that they're, now serverless or, using Lambdas or microservice or micro front ends and all those sorts of things. But ultimately, the developer feels the most risk at that point of release, and de-risking that was really kind of what unlocked it for them in terms of, feeling safe to get ideas out faster.
All systems are socio-technical systems, not just the technical system, right? Like no technological change is actually going to make a difference if your team is afraid to interact with production in any way because it pages them all the time or they get yelled at every time they cause an outage.
Mm-hmm.
So we have feature flags. Maybe we want to quick define that in like a few words, and then let's try to run popcorn
I think we should back up a
around.
step though, right? Like, when Claire was talking earlier about this idea of rolling out features to a percentage of users, right? Like, I think even going beyond a step beyond that, the critical insight that progressive delivery had was that you can decouple a release of software from a deployment of software, right? So when we are enabling the ability to turn on specific functions of our code at times of our choosing rather than at times of our not choosing, I think that is the key thing that then enables teams to better manage their own releases, right? Like, and then we can talk about the details of feature flags from there.
And then when we say rollout, for those that aren't as familiar with this concept, which James Governor kind of coined as progressive delivery, how do you decide who to release to or not?
Certainly people do everything from, hey, we're going to roll out just to 1% of users at random. There are also circumstances where you might have early access customers, right? Like you might have customers that have opted in. We actually just completed a pretty long process to turn on a new metrics backend at Honeycomb. And we had customers that wanted to opt in early. And then we had customers that were like, I don't want to be broken, right? Like, please don't give this to me early, right? Like, and that self-selection was really, really important for people to get that early access if they were more risk tolerant and they wanted to influence our future development, and for us to not break people that wanted to be a little bit more conservative. And then, there are also the people who decide, these users are free tier, I'm just going to experiment on them, right? Like they're not paying me any money, which is a fair business choice potentially. But I like thinking first about, who's more risk tolerant and then kind of figuring out, how you divide your users into risk tolerant and not risk tolerant from there.
There can also be, building on that, customers that maybe on paper are not risk tolerant in general, but they've had an issue with something and you're trying to roll out something that helps solve their problem. And most of the time in most of the businesses where I've had direct communication with the customer on these things, they're like, yeah, sure, we'll try it out. It might solve our problem. We appreciate you taking us seriously. And it is actually helpful to build relationships that way, which is, to me, an extra bonus on then making sure that the person who's got the real world problem gets the fix properly tested as well.
And that always jumps out at me is that's really well said, right? In that relationship building, because to me, the release process can be a great learning process. And if you do it progressively, if you do it incrementally, if you target how you release things, it provides opportunities for conversation, right? It provides an easy opportunity to say, is this working? Does it do the thing that you wanted it to do? Is it conflict with anything that you previously were doing? And you really get to enhance your ability to align, on the outcome that you're delivering with your customer, right? You can do some course correction, right? If you're not just turning it on for everyone and, getting some feedback and figuring out, oh, well, maybe there's an iteration on this that we need to do before we kind of go a little bit more broad around it. And so to me, progressive is there's the incrementing component of progressive, but it's really what can I learn at those increments and can I learn something different? Like one might be functional, another moment in that progressive delivery might be more around scale and reliability, right? As I increase
And
access to the
performance, right? Like,
feature.
if you see 10% CPU increase from turning it on for 1% of your users, you go, okay, right?
Mm,
Like that needs a little bit more work.
exactly. So, you can learn different things along the way, and that's what opens up your mind in terms of deciding, do I go 1% or 10%, or do I go a targeted list of alpha beta customers and then into a percentage, or maybe I never do a percentage, but I work with my community to get feedback at every step along the way.
Right, exactly. Self-opting into feature flags is also really, really awesome, right? Like,
Mm.
every time you have an
Yeah.
experimental or beta slider inside of your product, right? Like that's something that you should also be managing through your feature flag framework. But I think to Jen's original point about progressive delivery and about splitting up changes into smaller increments, right? Like when we're talking about splitting up into smaller increments, we are not just referring to the code, right? Like I think that is the critical thing, right? Like we are trying to get feedback faster, accelerate our learning cycle, not just by shipping code faster and in smaller increments, but also micro learning from smaller numbers of users faster rather than waiting to deploy it to everyone before we realize, oh, we built the wrong thing.
This is very interesting because usually the example for progressive delivery is roll out to, well, Australia or or
Hey,
maybe
stop picking on
Africa. Yeah.
Australia. We may be very few people and we may be in a strange time zone, but we're real users.
Yeah. And also the idea is like you're not being that responsive if it's not when your most of your staff is working. If you're Zero or another Aussie company and you want to release to Australia first, that's a choice, maybe logical. But I think these ideas of thinking about it more strategically, as you said, Ryan, to have a conversation is better. But on the other hand, you can dump it on people that are not worthy. Back when James Governor, I feel like it was 2017, but I don't know, first was introducing this concept, or the concept existed, but like coalescing around this term progressive delivery. He said like one client he knew dumped everything first on the people that used illegal or stolen credit or fraudulent credit cards as the first. To me, that's lower risk, and I get that. And if you're going to risk, they're not the customers you're really worried about. I guess on the other hand, it doesn't really show to me that you care about what you release that much and you want that feedback. It's really just, is this going to work or not? Not, this is a beautiful feature we are bequeathing to others.
Honestly, I think more teams, where possible, should dog food, right? Like,
Yes.
right, like Honeycomb's deployment cycle, we automatically deploy whatever's at main once an hour, but it goes through phases of first every Honeycomb employee gets it for our internal instance of Honeycomb before it goes out to production, right? So that also is a form of progressive delivery, right? Like, yes, it's progressing through environments, but like they're not throwaway environments. They're real environments that
Yeah.
our employees use, and we will scream if we notice something wrong.
Mm-hmm. That's the
Yeah,
platform engineering way. You're the
yeah,
worst and the best customers. Best tightest feedback loop, Claire.
yeah. We really are the best and the worst customers as developers. I mean, we did that at GitHub. There was a staff bar and things were enabled there. Plus, to Liz's earlier point, we had it was possible for customers to opt into certain feature flags themselves when they chose to as well. Again, at Netlify now at N8N, we're huge users of our own product, even if what it takes to build the product isn't exactly what you'd necessarily use for the actual, say, software development lifecycle. But we use it for all sorts of things internally because then, and we have what we call the internal instance, which to Liz's point, yeah, that does spot a lot of things before they hit the wider audiences.
I think one interesting AI tie-in here is that we've talked a lot about how AI puts stress on the system,
Yeah.
but I also see AI as an opportunity to make it easier to do progressive delivery in a lot of
Yeah,
ways,
I
right?
agree.
Like development teams struggle when you tell them, hey, can you, right, like, can you put a feature flag around this? And they're like, I don't know how to do this, right? Like, write a skill, have the agent create the feature flag, have the agent wrap the code, done, right? Like it's not just a technical debt generation machine, it can also be a technical debt paying down machine.
Yeah,
Yeah.
and AI is also going to support that debt elimination, right? The idea of understanding what's in use inside your application as it relates to a feature flag. Is it being called? Is it routing traffic? Is it no longer being modified? And AI, we're investigating ways that AI can interrogate your flags and say, are you worthy of still existing, right? And if not, we're gonna do a pull request, and we're gonna suggest that you get removed, right? So all stages of the life cycle can be affected by AI as it relates to flag management, in our opinion.
Also, what about other things? We're talking about feature flags, but there's so much more to progressive delivery. What about, has anyone used blue-green or A/B testing where you aren't really sure where you want to go and which is the best feature to solve this problem? How are you going about that?
I think that with regards to blue-green for infrastructure, like I think that that is a good thing to do if you can afford to do it. I think a lot of the challenge of blue-green is that it does require doubling your resource footprint, which may not be palatable at internet scale. However, infrastructure as code is making it cheaper to do that because you can certainly, temporarily provision that blue-green environment during the overlap period and then decommission the old one whenever you're satisfied. Whereas previously it was okay, well, now we have to keep a blue and a green running permanently. That's not so great.
Oh, yeah.
I think with regards to the other thing that you suggested, I think, we definitely can. I think it's definitely worth doing. Yeah.
Yeah. Okay.
It is. I think experimentation was an odd word to bring up with product engineering groups 10 years ago. Um, I think more and more I see engineering leaders adopting it as a key way to, quantitatively measure the impact of what they're doing. It's not a replacement for qualitative engagement, but it can enhance your overall, again, that learning experience. And I think A/B testing, I see it more and more being adopted as a pattern within engineering to, answer questions and answer them quickly. If we tie this back to AI, and AI development, I always say that there's a lot of knobs and levers in AI. There's things like models, and there's temperatures and parameters that you want to adjust. There's prompts that you feed into it. Nobody seems to get those knobs and levers right the first time. And so the ability to quickly change any of those individual components and then have a feedback loop in terms of what's the outcomes then from that adjustment. Am I seeing less hallucination? Am I seeing better, outputs from, let's say, if I'm doing a Gen AI, better outputs? That's very informative. And so I think in the AI world, it's underlining the need to do A/B testing, experimentation quickly.
And in fact, the AI world has a
Yeah,
term for this, right? Like it's evals, right? Like you want to
eval.
constantly be doing evals, right? Like, no
Thank
one
you.
disagrees with that. Here's the risk that I do foresee with regard to A/B testing, right? Like, yes, it's good when it's invisible to the user.
Mhm.
I worry that with the pace of AI development, the bottleneck becomes the rate at which you can churn user interface and right? Like users do not like it when you move their cheese. And being told you're in an A/B experiment test group, right? Like, and we moved your cheese to see how you reacted to it, right? Like at some point it grates on the user. So I think people are going to have to figure out how to prioritize, right? Like doing these A/B tests and not testing every feature on, the same set of unsuspecting users because they will get very unhappy when you keep churning their UI.
Yeah, there's an interesting tension there for me with the AI side because you've got the constantly changing churn. And yes, I've had enterprise customers at previous jobs say, "Why is the interface changing?" And you're like, "It's only changed once in a year," and they're like, not happy. But we're also like, there's the hyper localized, hyper personal software that's being built at speed, and like, where does this all play out over time. I don't have answers, but I think it's fascinating to live in it and see what's going on, to be honest. Where I would also say there's something we haven't mentioned here where AI can help with the experimentation is I've got some of that happening where we are now at NA10, and a couple of my engineers have actually used the AI around the analysis and around what to try next and what to tweak, and kind of use it as a investigative tool, rather than a here, let's just build a new UI or build or whatever. And we've found out some interesting facts that way that we might not have stumbled across otherwise, which is an interesting angle.
Can you give an example of like what you found that way or how that worked?
We were trying to, because obviously when you run experiments, you kind of, if you're doing it right, you're trying to figure out is this good or bad? Did we move a needle? The needle wasn't moving in the way we expected. And instead of just being able to shrug our shoulders, it enabled the team to do much more of an in-depth investigation into that, and then come up with some possible causes based on that, which they are now running further experiments on. So I don't have complete conclusions there, but it opened up routes that we might not have thought about taking, or like prompted us to think about it more deeply. And the engineers took this on themselves and were like, no, I need to understand this better, and just really hammered it. And I loved that.
One of the areas around progressive delivery, we're talking about, like, we've been talking about lowering and limiting blast radius. The other side of that is because of the rapid feedback. And that's something that both AI can make better. It's known for that because there's prototyping, there's different options. But also if your PR side's getting longer or the bottleneck was never writing code. So if as it moves down the line, there's a slower feedback that way, or maybe even this idea that developers didn't create the code, so they're waiting for feedback and they don't fully understand. So what are ways that we can tighten this feedback cycle with faster releases when we're releasing so much more?
I think that I think you have to lean on quantitative measurement a bit to get a faster feedback loop. I think picking up the phone is still the fastest, right? Engaging with your customers closely on individual changes, but unfortunately, that's also kind of a little more anecdotal in nature, and you'd be hesitant to take strong action based on a couple of data points. Whereas if you can measure things quantitatively, you should have greater confidence in behavior or action as a subsequent, subsequently from the signal that's delivered, right? I saw things improve, or I saw things degrade, or I didn't really see any impact on significant metrics. And so I think quantitative measurement enables the fastest operational process. Immediate feedback, though, you can still attain, qualitatively.
I think there is one interesting challenge, which is we know that language models do best when they get immediate feedback, right? Like, when they get immediate feedback on your tests are not passing, right? And how do we connect that loop back with production with what users are seeing? For reliability signals, right? Like, we should be connecting them to our observability tooling, albeit, that might be on a delay as far as, how often you release, right? Like, it might take half an hour or an hour, or heaven forbid, 8 hours for that to go out, right? Like, and then for you to be able to feed that signal back into the language model of this is how it's actually performing. And then I think, things like amplitude, mixed panel, right? Like things that are for user analytics are another place where you might want to feed that into the language model, although that starts getting in the domain of user requirements, which I think is more of a human consideration rather than a thing that a language model can directly do something about.
And I think the struggle that you'll have on the observability side is that it tends to not be cognizant of maybe individual changes that might be occurring inside the application, or you've got a situation where, of course, many things are constantly changing inside the application, whether it's other new features being introduced, or new capabilities, or new infrastructure, or new networking, or new security, what have you. There's a whole multitude of things, and so observability tries to take all that in and tries to find the problem, that's in the noise. And I think having a better sense of feature level observability, so changing the paradigm from measuring the application to measuring the individual change, is important to isolate that signal faster to take that action.
Okay. Something we did talk about was this sense of ownership in the age of AI. So even if AI is involved in or wholly creating things, who is in charge of the delivery of that thing and who owns it?
That's definitely been a big one for me. I'm very strongly of the belief is you build it, not necessarily write the code, but you build it, you kind of own it type of behaviors. I know there's various org structures that tweak that, but by that I mean I don't mind which tools you use. If you want to tap it out in binary by making a noise on your desk and have the sound recorder convert that into code, you go ahead. You'll be very slow, it won't be great. If you want to use an IDE, great. If you want to use AI to help you, great. But fundamentally, you're the one that is shipping that. There's still the human element of that. So you have to own that. To what level you want to understand that is probably down to the individual's confidence level on a bunch of things. But again, it's like at the moment we can't have agents sign legal contracts. We can't page an agent at 3 a.m. I know there's a few firms trying to claim that we can do that, but we still need humans for sure in so much stuff. And this is,
and also more importantly, who is doing the learning? Who is feeding that back into architectural
absolutely
strategy,
yeah.
right? Like there is a crucial role for humans to play.
Yeah.
Sure, we might be moving a level up of the abstraction stack, but you cannot remove humans entirely, or
Yeah.
you're just washing accountability.
Yeah, yeah. I've actually got a blog post offering exactly covering the kind of the learning angle of that because, yeah, the experiential stuff might be going away and we need to find ways to educate people. But yeah, I think the ownership does still very much sit with the humans, be that engineers or people like me as a leader or whatever. But yeah.
So now that we've established who should be, the buck stops with who is running this experiment, even if AI is implementing it. So how do you safely experiment in this time period? What is necessary for that?
I think that I think safe experimentation it is an understanding of the audience. I think Liz kind of pointed it out well. It's like we're all human, right? When you run an experiment, you're interacting with people, and you have to take that into consideration. I think a safe experimentation program uses some trusted methods, right? True randomization. It could potentially do isolation of experiments, keep out, control groups, from being exposed and using that as a baseline constantly to make sure that, you are preserving your users' access into the system and testing in a responsible way. But I don't know that anything in AI changes that shift from an application development perspective. That's my thought process anyways, is that AI it's software at the end of the day. It has end users at the end of the day. We have to be responsible to our end users. We have to be logical in what we're testing. And, are we creating an opportunity to learn something, given the parameters of the test and, what our hypothesis might be? And if you're confident, you can say yes, then you've got a safe test on your hands.
I think much like the ownership angle there, the the person working in growth, be that a PM or a growth person or even the engineer, they can't abdicate the responsibility around how you would design and then roll out the experiment, much like they've done in the past. That still holds.
Yeah, I would say responsible experimentation requires that you have a well-functioning release process. It requires that you have feature flags. It requires you have observability, right? Like there is a certain level of operational table stakes maturity that is required. Because if you're just flipping flags, right, like, and you can't actually measure the results, like you are not actually experimenting, you're just injecting chaos. right? There's a reason we talk about chaos engineering, right? And I think that when we talk about progressive delivery, right, like you have to actually deliver something and validate it.
It's
That's
like having a light switch in this room, controlling a light in some other room, and you're just flipping it on and off, and you have no idea that you're causing chaos.
yeah, absolutely. We did have a question from the audience. So there, it's a very broad one. So the idea of how do you quickly and safely recover from incidents after a release when many subsequent releases or deployments have happened since? So this is definitely a smaller releases, traceability, observability. What else can help this anonymous attendee? Thank you for your question. Do this quicker, safer recovery.
I think if I understand, I think what we have to know is what's the source of the problem. I think if you don't have certainty about that, then you tend to roll back a lot of things in the hopes that you capture, the underlying problem. My belief is that if you are working in smaller and smaller units and putting those units behind code units and you putting those things behind flags, you have a greater chance to better understand if a specific change is causing that problem, in which case you can, it's a term that we use in the industry, you can kill that flag, you can turn off that negatively impacting experience while leaving everything else in place. If you don't work in those small units and you don't work behind flags and an incident is discovered and there are many releases between now and the incident, what can you do? You can try to triage and obviously try to get to the root cause. That means that pain will continue to exist until you can figure that out. You can do a general rollback strategy, which might cause its own friction because people were enjoying the use of something that suddenly might get taken away because we're not sure if that was causing a negative consequence. And so you kind of have to, you know, I would say you have to understand the changes. You have to control those individual changes more to be able to not get into that cycle of, rolling everything back.
Certainly, as a reliability practice, if you are discovering issues relatively quickly after they happen, the rollback is the safest way to get into a known good state. We know that fixing forward can introduce all kinds of complications. But the argument is when you have feature flags, you can revert to a known state without changing any code, just changing the feature flags. And I think in that state where you have had a number of deploys and an issue was latent and then it surfaced, right? Like, yes, a fix forward may be your best option, right? But a lot then goes into resilience strategies, right? Like, how are you making sure that it's only a smaller blast radius of users who are impacted, right? Like, how are you quantifying who those users are? Are you able to communicate with them, right? Like, there's so many things that go into a user's perception of how bad an outage was, that are not strictly related to the duration of the outage.
It could be the impact, it could be financial, it could be just how much it annoyed their day if they're the individual contributor that's using that tool. All these matter. And something we've been talking about the impact and speed of AI and just there's more of everything. But I think this is going to be the year where we're not just we're going to hear about agents all the time, but I think we're going to hear about them also in the ops world because this agentic operations, agentic is interesting because maybe a specific skill can be trained around this threat posture that you have, that if you reach a certain threshold or something, if that CPU spiked up like you said, Liz, maybe it's something that the AI will do something or at least help you with your root cause analysis because it can process more information. Buck stops with that developer that's in charge of the AI, but still maybe.
Right, like I think this is one of the really cool and exciting things that we're starting to see our customers do with AI that we're doing ourselves. And AI doesn't care about being wrong. It can investigate 6 different parallel strands, right? Like, whereas a human can probably only investigate 1 or 2 investigative hypotheses at the same time. right? At the end of the day, someone does have to make a decision about what we are going to do about it and to feed that learning back into our software development process. But as far as being able to find a bug quickly, that is starting to become faster for a machine to do than for a human to do, which is tremendously exciting.
Mhm.
I was going to build on that.
Please.
Both the fact, like kind of Liz said, that if you've done multiple releases and not found the issue, because I mean, when we did big rollouts of things, you tend to be watching dashboards like a hawk and looking for any sign that something's not quite right. So you can spot that early and roll back quickly and then figure out the whys and wherefores on that one. But to that point, the other thought that popped into my head was I remember, again, this is a GitHub memory, but when things went wrong, we did a lot of Git bisect and things to try and work out what might have changed that caused these things. And one of the really lovely things for me about AI tooling is that, having joined a company relatively recently, I don't have to go through all of the Git bisects and do it, or Git logs and try and work stuff out. I ask the AI to figure this stuff out for me in the code base, and that's way faster. And to that point, parallels, so we can help ourselves. We can have it help us and do that amplification that you mentioned right at the start.
Just to take one last question from the audience, and it's kind of a big question, but I think we can make it a littler, and I think Ryan, you kick off with this. Rajiv, thank you for asking, how would you design a formal life cycle and architectural strategy to ensure that feature flags remain a temporary scaffolding rather than a permanent complexity? And how do you enforce the removal of these flags once a feature is 100% rolled out? Which that's very interesting. You said, Ryan, you alluded to that you're testing AI for this now because it can be like, hey, we think this is old, which we love to stop zombie things from running environmentally and cloud costs. But go more, Ryan.
Yeah, there's quite a few things in that question, right? First off, I think you're getting to the difference between having a feature flagging system and having a feature management system. I think a feature flagging system can be implemented in a variety of ways, and you hear it, whether folks are doing config files or whether they have database toggles or a variety of other mechanisms that create some code isolation and the ability to then change, the behavior of that code. Feature management, in my definition, means that flags do have a life cycle. There are flag types. There are long-running flags, just to be clear, right? There are often short-lived flags to support feature releases, but there are long-lived patterns that make a lot of sense.
For sure, right? Like, when we're talking about the difference, there's a difference between I have this code that I want to enable and disable. I'm doing a migration from path A to path B, right? Like that's clearly a short-lived flag. You should be notified. You should have your agent rip out the old path when it's no longer needed. But also we have things like, we call them control rods, like a nuclear reactor, right? Like, hey, we need to emergency drop load, right? Like, that's not something that you want to take out of your code base. Or here's the configuration for how many segments we process in parallel per worker, right? Like, again, that's something that you might want to runtime to. So I think knowing which one is which, having that taxonomy, having the hooks into your agentic system to make sure that they are, that they're able to control the rollout of the flag and also to receive the signal that the rollout is done and to rip out the code, right? Like that's kind of that direction that's going.
Yeah, so once you have that ability to define flag types that your organizations are using, then you can define that life cycle around them. How long should exist? Where should they persist? What's the naming? What's something as simple as the naming convention of different types of flags to better understand their purpose inside my code? And so you want the ability to interrogate your system to understand what's operating in any given time inside your application and what's the state of that flag once it's discovered, because an inventory of flags gives you nothing, right? It doesn't say if I have 100 flags or 1,000 flags, I can't say whether I have a healthy implementation. It's what are those flags doing? Should they be there? And if they don't have a purpose, to the last part of your question, how do we remove them? Now, I've experienced a variety of mechanisms in terms of preventing that. I have customers that actually prevent developers from implementing new changes until they retire flags, right? They prevent actual pull requests from going through. It's pretty draconian. It's kind of hard-handed, but that's a symptom. We're obviously trying to find nicer mechanisms, things to support the engineer in their effort of managing this, because there's a lot of cognitive load associated with using flags. And so AI for us is, for us, what we think is going to help an engineer the most in managing that life cycle and just saying, hey, kind of seems like this is no longer in use. You're the human in the loop. Can we remove it and take some action on your behalf?
I think one other interesting piece that you discussed was the kind of validation and the knowing what the landscape of what's out there, right? If you are not attaching the state of each flag to each request, right, like then you are not getting valuable telemetry data about, hey, this outage might be affecting only users with this particular flag set, right? Like, so that operational data is really, really important to feed into your processes.
We could talk about this all day. I think if we're going to end and wrap on a note, all of these, we're talking about technical solutions to a socio-technical problem. We all see great value in the developers, the operators, the humans in the tech processes. And everything we're talking about is hopefully making your lives a little easier, because that was supposed to be the idea of AI. It's supposed to let us work on unique, interesting, novel problems. So hopefully we wish that to you. And with the AI of things or not, progressive delivery is one of those best practices that will help you succeed, get fast feedback, and be better at your work. So we wish you luck, and we'll see you in the Lead Dev Slack if you need anything, and we'll see you at the next one. Have a great day, y'all. Thank you so much, Liz, Claire, and Ryan. Thank you.
Thank you.
Bye, everyone.